the ground due to perspective. As they come together, that's the limit of your vision. That's called our horizon. The horizon is optical. If you had a super zoom camera, you can zoom in and make this angular size bigger to reveal small objects that you couldn't see. And then when you zoom out, it goes back together and things disappear into the horizon, not over.
Right here, we have a perspective grid. Okay, this is not a conspiracy theory. It's a grid. Just showing you that the sky goes down and the ground goes up and the viewer is at that middle line. So we have a guy looking down. His eyesight is at that middle line. This is, we can all agree on this, flat earth, globe earth, whatever you want. Okay. And so we have a mountain. Now this mountain is thousands of feet above this viewer as he's looking at the mountain. And we'll watch the sun going away. It's going away. It's not going down. Go watch my Flat Earth Kitchen video if you think that's going down. And it's now beyond the mountain. We know it's not below the horizon. It's beyond where this viewer can see it. Now, if he got up high, higher than the mountain, he would be able to see the sun again. Okay? So does that prove globe earth or flat earth? I don't think it proves either. Okay, because this is just how perspective works. Now, let's move that mountain into the distance, just following the perspective grid. And as it goes all the way into the distance, you can now see a much wider area farther away. So let's fill in that area. So here's that mountain, thousands of feet above his eye level. Fill in the foreground. And it's thousands of feet above his eye level. But it looks like it's at his eye level. The sun will go away, just following that perspective grid, and it's going beyond the mountain. It's beyond the mountain. Now, again, if he went up high, he'd be able to see it again to a point when it's that far away, right? So now let's fill in the sky. We have the Atmos layer, thanks, Austin. which is clouds or even clear air, but over distance, all of that gets compressed into the horizontal eye zone. Okay, it becomes opaque over distance, but we'll look at it with clouds today. And then you have the celestial layer, the sun, above it. Okay, so the terrestrial viewer looking through the atmos to a celestial object above it. As it goes away, it's not going down, it's just going away. It goes beyond, it's going beyond two things right now. All of this clouds and atmosphere becomes opaque again. Okay, so if there weren't mountains there, it would just go behind the clouds, beyond the clouds, which are tens of thousands of feet over the person's head, or maybe 10,000 feet, who knows? It goes beyond. That's it. Now, the reason that you can't see it again by zooming in is because, one, the mountains are blocking it. Two, the atmos cloud level is blocking it. And that's it. Now, on a flat Earth, when you're over a flat surface like water, and there's not too many waves, you could lose sight of a ship, but you can open up that layer because you are on the ground layer looking at something in between those layers, but you can't see something that's above the layers because it is cut off from view. There's no denying this. What do you have to say about that?